This video is actually a continuation of our topic, Doppler Effect, and this problem that we're going to analyze now is that the listener is moving while the source of the sound is stationary. Okay. All right. So before that, let us review first our previous problem that we just worked out a while ago. In the previous problem, we determined the frequency of the sound that is received by the listener from the police siren that is moving 30 meters per second. Okay, and also the velocity of the sound that we're using in this problem is the same, 340 meters per second. So what we did is that since the listener is at rest, okay, we equate V sub L to 0. That is why the formula that we used is V over V plus Vs times the Fs, or the frequency from the source. Now, in this problem, the example 16.8 is that the listener, okay, is moving away at 30 meters per second, and the source of the sound is stationary, as what you can see here in our illustration. All right, and the velocity of the listener in this problem is the same, 30 meters per second. Now take note that we are going to use again the same magnitude of the speed of the sound, that is 340 meter per second. Okay, now let us identify and set up the equations that we're going to use. All right, now since it is said in the problem that the source is stationary, so we equate V sub s to 0. All right, so V sub s is equal to 0. And since the listener is moving away from the source, we use the negative sign here. That is why we have negative 30 meter per second. Okay, that is our V sub L. All right. Now this is very important. Okay, to establish prior to the computation using the equation, because this will identify the direction. Okay, um, of something like the source or the listener. So in this case, we show that it is a negative sign because the listener is moving away from the stationary source. All right. Now going back, since the V sub s is equal to 0, so what we did is we did not anymore write the V sub s at the denominator of the equation. So we have the equation here, F sub L equals V plus V sub L over V, okay, times the F sub S. All right. So again, we don't have the V sub S here because the source of the sound is stationary. Okay. Now, and also, yes, it is negative 30 meter per second because the listener is moving away from the source. All right. Now, let us plug in the values in the equation. So we have here 340 meter per second. That is the speed of the sound in the air, and negative or minus 30 meter per second. This is the speed of the listener that is moving away from the listener, and also divided by the 340 meter per second, that is the speed of the sound, okay, in the air. And of course, we're still using the same frequency because the source is emitting or releasing 300 hertz. Okay, so this is our V sub S. So to compute the frequency that is received by the moving listener, okay, is 274 hertz. All right. Now take note that the frequency is again less, all right, less than 300 hertz because the listener is moving away from the source. This is just the same with the previous example, that the frequency received by the listener, although what is moving here is the source, okay, is still lesser from the frequency of the sound that is emitted or produced by the source.